Machine Part 2, ICSE Class 10. The topic for today: principle of a machine, principle of a lever, kinds of lever. Now first, principle of a machine. In a machine, the output work, that is the output energy, can never be greater than the input work or input energy, because it will violate the law of conservation of energy. Now, in an ideal machine, the output work is equal to the input work. This is called the principle of a machine. So, output work or output energy is equal to input work or input energy. Now, an ideal machine is that in which there is no loss of energy in any manner. The efficiency of an ideal machine is 1 or 100%. But in an actual machine, there is always some loss of energy. That means output work is less than input work. The loss in energy is mainly due to the following reasons. Number 1, the moving parts are neither weightless nor frictionless. Number 2, the different parts are not perfectly rigid. Number 3, if there are any strings in the machine, they are not perfectly inextensible. Now look at this example of a lever. Suppose it is an ideal machine. Here, effort is equal to 25 Newton is used to lift a load of 50 Newton. It is a force multiplier. Here, displacement of load is 1 meter, as you can see in the figure, and displacement of effort is 2 meter. So the work output is equal to load into displacement of load, that is 50 Newton into 1 meter, that is 50 joule. And work input is equal to effort into displacement of effort, that is 25 Newton into 2 meter, that is 50 Newton meter or 50 joule. So we see work output is equal to work input. Let us consider another example, ideal case. Here, an effort of 50 Newton is used to lift a load of 10 Newton. So this is not a force multiplier. We see that displacement of load is 5 meter and displacement of effort is 1 meter. So load has moved a greater distance than effort in the same time interval. So this machine is a speed multiplier. Now the work output, load into displacement of load, 10 Newton into 5 meter, that is 50 Newton meter or 50 joule. Work input, effort into... Here the work input, effort into displacement of effort, that is 50 Newton into 1 meter, that is 50 Newton meter, that is 50 joule. So we see that a machine may multiply force or a machine may multiply speed, but it does not multiply energy. A lever works on the principle of movements. That is, clockwise movement of load is equal to anti-clockwise movement of effort. So load into load arm is equal to effort into effort arm. Now from the figure we can see that triangle LL-F is similar to triangle EE-F, and we also know that velocity ratio is displacement of effort by displacement of load, and mechanical advantage is equal to load divided by effort. And from principle of lever, load into load arm is equal to effort into effort arm. By transfer of side, we have load by effort is equal to effort arm by load arm. And we know that load by effort is equal to mechanical advantage. Therefore, effort arm divided by load arm is equal to mechanical advantage. So, we have one more formula for mechanical advantage in case of lever, that is effort arm divided by load arm. Now, again from figure, displacement of effort is equal to E dash and displacement of load is equal to L dash, and effort arm is equal to EF and load arm is equal to LF. So we can write velocity ratio as EE dash divided by LL dash and mechanical advantage as EF by LF. Now in maths you have learned in similar triangles ratio of corresponding sides are equal. Therefore EE dash divided by LL dash is equal to EF by LF. Therefore velocity ratio is equal to mechanical advantage in all ideal cases. Now we come to kinds of lever. There are three kinds: class 1 lever, class 2 lever and class 3 lever. Look at class 1 lever. In class 1 lever, the mechanical advantage can be equal to 1, can be greater than 1 or can be lesser than 1. The first case, when effort arm is equal to load arm, mechanical advantage is equal to 1. Second case, as you can see, effort arm is greater than load arm, mechanical advantage is greater than 1. And third case, effort arm is less than load arm. So here the mechanical advantage is less than 1. Now let us come to class 2 lever. In this class of lever, the mechanical advantage is always greater than 1, because as you can see in the figure, effort arm will always be greater than load arm. Class 3 lever now, here the mechanical advantage is always less than 1. As you can see in the figure, effort arm in all cases will be less than the load arm. Now this will be a speed multiplier, class 3 lever, and class 2 lever will always be a force multiplier. Also in ideal case, mechanical advantage is equal to velocity ratio. Now we come to examples of different classes of lever. First class lever, a very good example is a seesaw. You can see one side we can consider the load, other side effort and fulcrum in between. Example of second class is a wheelbarrow. You can see the load is in between, the force is acting downwards, force applied by load, and effort is acting in upwards on the handle. Fulcrum is at the wheel. Class 3 lever, a very good example is a fishing rod. Here you can see the effort is in between the load and the fulcrum. Now a point to ponder: which of the two formulae to find mechanical advantage of a lever is more accurate? The first one, mechanical advantage is equal to load by effort, or the second one, mechanical advantage is equal to effort arm by load arm? Think about it. Now the following question will help to shed light on the above question. The question is, the given figure shows a uniform meter rule of weight 100 gram force with fulcrum at 30 centimeter mark used to overcome and load of 300 gram force by applying an effort of 100 gram force at other end. Find the mechanical advantage of the lever by both the formulae. Here you can see the load arm is 30 centimeter and effort arm is 70 centimeter. Now, according to the first formula, mechanical advantage is equal to load by effort, that is 300 gram force divided by 100 gram force, that comes as 3. But according to the second formula, that is effort arm by load arm, that is 70 centimeter by 30 centimeter, it comes as 2.33 approximately. Both these values do not match. Why? Here the weight of the lever has been neglected, that is 100 gram force acting through the center of gravity of the uniform lever, which in fact is helping to overcome the load in this case. Now, according to principle of movement or principle of lever, anti-clockwise movement is equal to 300 gram force into 30 centimeter, that is 9,000 gram force centimeter, and clockwise movement that is 100 gram force into 20 centimeter plus 100 gram force into 70 centimeter, that is 2000 gram per centimeter plus 7000 gram per centimeter, that again gives 9000 gram per centimeter. Here you see in written in red is 100 gram force into 20 centimeter. That 100 gram force is the weight of the ruler. So we see here anti-clockwise movement is equal to clockwise movement. And so we come to the conclusion that mechanical advantage is equal to load by effort is more reliable. That's all for today. Solve the questions of the chapter. And goodbye, and we'll meet again very soon. Take care.